Okay, so these are really exercises, but I'm going to go through it with a video just to show an explanation. So here is an example of another number trick, just like we did in the first lesson. So it says choose a number, add 3, double the sum, subtract 8, divide by 2, subtract the original. Okay? Repeat it 4 times, different numbers. So there's not a whole lot of space here. So make a little bit of space or do it on the back of the page or on your own page. If I choose a number like 1, if I add 3, I get 4. Double that, I get 8. Subtract 8, I get 0. Divide by 2, I get 0. Okay? And then subtract the original number is -1. Don't end up with the original number. Let's do it with a bigger one. How about 5? Add 3 is 8. Double the sum is 16. Subtract 8 is 8. Divide by 2 is 4. Subtract the original number. 4 minus 5 is -1. I get the same number as the last one, but I started with a different. Let's do a negative. How about -3? Add 3, I get 0. Double it, I get 0. Subtract it, I get -8. Divide by 2, I get -4. Subtract the original number. So when you subtract a negative, it's like adding. You end up with -1. Okay? So you can keep on doing that. You always end up here with the value of -1. So it says, write a conjecture about the final number. So the final number is, so basically, if this number trick is performed, the result will be -1. Okay? Prove your conjecture. So let n be the original number. Okay, so again, not a whole lot of space. So we're going to then go in steps. So n is our original. Add 3. Double that. Subtract 8. Divide by 2. Okay, and then subtract the original number. You'll always get -1. Okay, so that is how it works. So go step by step. Don't try to do all of it in one step, because probably you'll get the brackets and all that kind of thing messed up. Another example, calendar. So here's a month and some cells here, some days are highlighted that form a square. So it says pick an array of numbers as shown. So basically 2 numbers next to each other and up and down. Find the sum of the numbers that are in opposite corners. So 7 plus 15 is 22, and 14 plus 8 is 22. Okay? Repeat this for other arrays. So maybe you do this one. So this one would be 23 and 31 would be 54. 30 and 24 would be 54. Okay? So the same thing happens. So write a conjecture about the sums of the numbers in opposite corners. So the sum of numbers in opposite corners of a 2 by 2 array in a calendar are equal. Okay. Prove your conjecture. So we have to, so let x be top left corner, I guess, value. In this case, the date in the top left corner. So then we would have, what are we adding here? So x This would be, so let's label it, that would be x. This would be x plus 1. This is a week later, so that would be x plus 7. And though this would be x plus 8. So we're going x plus 8 is 2x plus 8. And then the other diagonal, x plus 7 plus x plus 1 equals 2x plus 8. Okay? All right, and those are equal. Right? Another pattern. Use inductive reasoning to complete the next two rows. So what's happening here? 1 is 1. 1 plus 3 is 4. 1 plus 3 plus 5 is 9. 1 plus 3 plus 5 plus 7 is 16. So what are you adding here? You're adding odd numbers. Okay? So 4 odd numbers, we get 16. First 3 odd numbers, we get 9. Take a look at these numbers. What do you notice? They're perfect squares, right? And this is 4 squared. This is 3 squared. This is 2 squared. This is 1 squared. How many numbers, odd numbers are added here? 4 of them. How many here? 3 of them. How many here? 2 of them. How many here? 1 of them. So what is special about the sum numbers 1, 4, 6, 9, 16? They're perfect squares. What is the relationship between the sum numbers and the number of odd numbers being added? So that is the sum number, the sum number is equal to the sum of the odd numbers. So what would be the sum of the first 25 odd numbers? That would be 25 squared, which would be 625. Write a conjecture about the sum of the first n odd numbers. So that would be, so the sum of the first n odd numbers is n squared. There's my conjecture. I kind of abbreviated it there. Use the sum of an arithmetic series formula to prove your conjecture. Now, you actually haven't done the sum of an arithmetic series yet. We will do that this semester. I'll give it to you just so you have it. Okay, so it's n over 2, 2 times the first term in the series. Series is a pattern of numbers. Arithmetic means you keep adding the same number. So basically S is the sum. So n would be the, so in this case, basically here, just going to want you to simplify this. So let's see if we do this. In our T1 is our first term, so whatever we're starting with, which is 1. So 2 times 1. N, so n in this case is, we don't know how many terms, so we want to keep it as n. And D is what we keep adding. So in those odd numbers, you keep adding by 2. So now let's simplify this algebraic expression. So we get 2 plus 2n minus 2. Well, that adds to 0. So then we get n over 2 times 2n, which is just n squared. So, and that's what we thought it was, what the sum is. So that's just some exercises explained to you in the video.